So we have reached our final method of solving quadratic equations. We've looked at graphing and factoring and solving by square roots and completing the square. And so now we're going to look at the quadratic formula. And so here's the quadratic formula. So it looks a little bit confusing, but the x value answer to any quadratic equation can be found by taking negative b plus or minus the square root of b squared minus 4ac all over 2a. A, b, and c are coming from your original quadratic equation. It's the coefficients of x squared, x, and the constant. So this first example, I just wanted to show you that the quadratic equation will produce the same solutions as factoring. So here's my first example. Here's my quadratic equation. So if I wanted to show you this one by factoring, remember I'm doing the diamond method for this trinomial. I'm coming up with the factors of 15 that would add up to negative 8. So that sounds like negative 5 times negative 3. So my solution for factors, x minus 5, x minus 3, when that is set equal to 0, my two final solutions for my x-intercepts are positive 5 and positive 3. So I want to show you that the quadratic formula produces the same answers as factoring. And then I'm going to show you the quadratic formula when you can't actually factor. So you would just use factoring on this example and you'd be finished. I'm just comparing how the quadratic formula works to factoring in this example. But if you can factor, to me, that's an easier method than the quadratic formula. So my first step is to identify A, 1x squared, B, negative 8 from negative 8x, and C is 15. I'm going to plug A, B, and C into this formula up top. So x equals the opposite of B. So if I have negative 8, now I've got positive 8, plus or minus the square root. B squared in this case is positive 64, negative 8 times negative 8. So positive 64 minus 4 times A is 1 times C is 15. So I've plugged all of those values into the formula. And then all of that at the end gets divided by 2A, which is 2 times 1. Now, students sometimes have trouble simplifying this expression with the correct order of operations. So I want to show you my normal steps. My first step is I figure out what is under this radical. So this I could do in my head. I have 64, and then I'm subtracting this number. I know that 4 times 1 times 15 is 60. So I have 64 minus 60. So I think you would agree that that is the number 4. I have 8 plus or minus the square root of 4 divided by 2, because 2 times 1 is 2. Well, 4 is a perfect square. So this is really equal to 8 plus 2 divided by 2 and 8 minus 2 divided by 2, right? Because I get two solutions. I get plus or I get minus. So 8 plus 2 is 10. What's 10 divided by 2? 5. 8 minus 2 is 6. What's 6 divided by 2? 3. Didn't I just get the same two solutions, 5 or 3, as my x-intercepts using the quadratic formula? Okay, so we're going to try a few more examples together. This time, example 2 is not factorable, right? There's no factors of negative 3 that would add up to negative 7. So now I have to do the quadratic formula. So A is negative 1, that's the coefficient of x squared. B is negative 7, and C is 3. And I'm going to put all of that into the quadratic formula. I'm going to write it up at the top. The opposite of B plus or minus the square root of B squared minus 4AC all over 2A, just to save us from flipping back and forth. So the opposite of B would be positive 7 in this case, plus or minus the square root. B squared is negative 7 times negative 7, so 49, minus 4 times A, which is negative 1, times C, which is 3. all divided by 2a. And 2a in this case is 2 times -1. So I simplify under the square root first. So I'm taking the number 49, and a double negative is actually adding. I'm going to add 12 because -4 times -1 times 3 is actually +12. And if you're not sure, you can do it on your calculator. 49 minus 4 times -1 times 3. So 49 plus 12 is 61. 7 plus or minus the square root of 61 divided by -2. We have the choice of leaving this in reduced radical form or putting it into decimal form. Technically, that is your solution, right? That's reduced radical form, and I've got my solution. It just doesn't mean a whole lot, so I think using a decimal makes a little bit more sense in this case. So I'm going to do 7 plus the square root of 61 divided by -2, and 7 minus the square root of 61 divided by -2. So I want to show you how to do those on your calculator. To do the first one, you want to do 7 plus the square root of 61, then hit enter. So the numerator is 14.8. Then I'm going to divide by -2. So I get -7.4 as my first x-intercept, -7.4. And my other x-intercept is 7 minus the square root of 61, hit enter, divide by -2, 0.4. So 0.4. So my two x-intercepts are -7.4 or 0.4. To me, that's more meaningful than this expression, but this expression is exact. All right, so in example 3, there's something a little bit different between example 3 and example 2. Did you notice something? It's not equal to 0 on the right. So I need to make it equal to 0. So to make it equal to 0, I'm going to subtract 4 to the other side. 4x squared plus 8x plus 3 equals 0. So I've subtracted 4 to the other side. So now I can identify A as 4, B as 8, and C as 3. So now I'm going to put that into the quadratic formula. So I've got the opposite of B plus or minus the square root of B squared minus 4 times A, which is 4, times C, which is 3, all over 2A, which is 2 times 4. So what do you notice here? Does anyone know what -4 times 4 times 3 is? I think it's 64. 4 times 4 times 3 is 6. Oh, it's only 48. Never mind. So I've got 64, and I'm subtracting 48. 64 minus 48 is 16. So I've got -8 plus or minus the square root of 16 divided by 8. The square root of 16 is 4. So I've got -8 plus 4 divided by 8, and I've got -8 minus 4 divided by 8. So these are going to come out as nice fractions. What is -8 plus 4? -4. -4/8 is -1/2, last I checked. And this one would give me -12 over 8, which would be -3/2. Right? -12 divided by 8 is 3/2, right? Okay. So there's my two solutions for example 3. So I would like you to pause the video before I do example 4 to make sure that you understand the quadratic formula. So now I'm going to show the answer to example 4. So it would be the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. What is 4 times 2 times 9? 72. I get -8 plus or minus the square root of a negative number. What happens if you have a negative number under your square root? You can't do it. So there's actually no solution. There would be no x-intercepts to this quadratic. So I'm going to do the discriminant in a separate video. So right now you can pause this video, and I'm going to do the discriminant in a second video.